Thank you so much. Good afternoon, everyone. So yeah, Mike Simpson, Chief Commercial and Product Officer for Cheesecake Energy. I'm an aerospace engineer by background, but decided to do something a little bit cleaner with my working life. So I'm going to talk a little bit about how energy storage can play a role in unlocking low carbon energy networks. And I'll also introduce a little bit about what our technology is and what it does. Fantastic. Okay, so we're in an interesting time. We've got a real confluence of factors that are making it tricky for energy users. Energy bills have been high. We hope they're going to come down a little bit, but the pressure to decarbonize is going to stay strong, and that's only going to build. And we're also seeing in the UK and abroad really high pressures on getting grid connections. And that can be in terms of the cost, but also delays. Increasingly, it's taking years and years to get the power that customers want. And it's stopping projects. It's meaning that factories can't expand. It means that logistics depots aren't going where they should. So there's a real pressure to see something different happen. So we've developed an energy storage technology that's a little bit different. It's based on storing heat and compressed air. Now, it's a modular design. We have 150 kilowatt power modules and 750 kilowatt energy modules. So these aren't huge. This is a relatively small technology that can serve a supermarket or a logistics, a warehouse, for example. It's based on proven industrial hardware, and it kind of has to be, because we've got to solve this problem pretty much now. We haven't really got time for things to go wrong. So it's about using what's already around us. It's containerized, it comes in shipping containers, the sexiest form known to man, and therefore the shape that all storage must come in. And it's very sustainable. So we use a lot of circular economy approaches, and I'll talk through those in a moment. So what's under the hood? Well, it's a thermal and compressed air system. When we've got surplus electricity from the grid or from solar, we use that to run an electric motor. That motor powers a piston air compressor. The air is compressed by that compressor, and we store the pressurized air, but we also store the heat. When you pressurize air, it heats up, and we store that in gravel or in sand. Once we're finished charging, we just run the process in reverse. So we take the air, we heat it up, and we pass it back to those same piston machines. So we're using the hot pressurized air to drive the pistons and turn the motor as a generator. And this is a really neat solution for electric vehicle charging, for industry, for microgrids, and others. Now, I mentioned circular economy. Well, we do want to reuse hardware. So we store the air in pressure vessels that we take from the compressed natural gas industry. There's already a supply chain of tens of thousands of these available each year. We use gravel or sand to store the heat. And those compressors, those piston compressors, well, once upon a time, they were truck engines. So these are Volvo truck engines that are repurposed into our reversible compressors and expanders. And we have our own little valve system that sits on top, allows us to run them both forwards as compressors and in reverse as expanders. And finally, and not to downplay this, actually it's about using what people already know, using existing skills, using existing infrastructure, because we want this to scale up. We haven't got that long to fix issues around climate change, issues around grid connections, issues around the energy transition. So let's use what's already around us. And there's plenty of people out there who can service a truck engine. And plenty of those people are perhaps going to be wondering, once we go to EVs, what are my skills going to be used for? Well, this might be one answer. It's also interesting to think of what the big industrial players that we have around us today are going to be doing in the future. Not everyone can turn into a battery company. But actually a lot of manufacturers could see their systems, see their factories being used to produce these units. This is about putting engines and motors into shipping containers with heat exchangers and pressure vessels and pipework. There's a lot of people that can do that. And that offers manufacturers the chance to be part of a transition not be frozen out by a transition. So what would this be used for? Well, it's really in the commercial and industrial space that we see the biggest applications for this. It might be industrial energy users that are looking to expand their factory, but they can't get the connection. It could be business parks and mixed-use developments that are facing high energy bills, that want to use solar, they want to generate energy locally, or even off-grid communities, or communities with weak grids that are seeing blackouts. So there's a range of opportunities, but all of them have in common this opportunity to use solar or wind in conjunction with storage to provide that dispatchable power. So yes, there are lots of benefits, and microgrids can be a big part of that as well. So allowing you to run somewhat independently from the main grid. If the capacity isn't there, well, provide it yourself. Be part of the solution, not just wait passively for the grid to catch up. Of course, microgrids they're not a panacea. So they come with complexity, and we want to be clear about that. There is complexity. There are more parties involved if you're doing a microgrid. It involves some investment, and it does involve some contracting, and everyone loves contracting. But actually, what it unlocks can be really, really exciting. So this is a project that we've just kicked off. Pleased to say we've had fantastic support from the UK government on this, the Department for Energy, Security and Net Zero. And this will see our systems being deployed in Colchester. Now, Colchester is an interesting place because it's one of the fastest growing cities in the UK, but it has a really poor connection, really, really constrained grid connection. So when we spoke to the local authority, they were telling us if we want to build a new office building, we have to take the kettles out of the previous one. So it's really, really tight. But this can be one of the solutions. So they're putting in an 8 megawatt solar farm on this site, and we'll use our energy storage systems to make that power available through the evening and actually meet the demands of the site. The site will be about 12 megawatts of demand, but they've only been offered 5 megawatts of grid connection. This is about how do we use storage to boost what the connection can give you and what storage can give you. And it can make the difference between a project going ahead or not. We want to make sure that people are using solar PV locally. It's going to be the cheapest form of power. This system will be designed as a microgrid, so the whole system can be islanded. There's a reliability element to that. So if the grid does go down, you've got options. But it's also about keeping the energy costs low. So when you're importing from the grid, do it when the power is cheap. Don't wait for the peak times, 4 till 7 p.m. in the evening, when it's going to be most expensive. And there's also a heating element to this. We store a lot of our electricity in the form of heat. And that means we can actually link in with thermal systems around us. So this site will have a district heating network and a heat pump. So we'll be playing with those as well. Now, the little kicker in this project, the grid upgrade that they would otherwise need to run this project could cost 10 to 15 million pounds and take years. So this is really a game changer. So I'm going to keep it short and sweet because I'm really interested to hear some questions. This is our technology, thermal and compressed air energy storage. We want to keep it really, really sustainable, reusing a lot of hardware, and keep it low cost. And it's a very flexible and scalable solution. We're looking to work with development partners, manufacturing, distribution, but also looking at pilot opportunities. So if you're interested in what a medium scale, medium duration energy storage system could look like, definitely grab me afterwards. We also have we've got a stand out there with a 3D printed model. Do come and grab me. Thank you so much. Welcome any questions.
Great, thank you. Any questions from the audience? Great.
Hi, looks really, really interesting. What's the efficiency of the process, please?
Yeah, so the efficiency of our system is a little bit lower than lithium-ion batteries. So we're looking at 55 to 65%. So a lithium-ion system, you might see kind of high 80s, 90%. But actually, this is a much longer lasting system. And it's actually targeting a slightly different niche. So, yeah.
Nick Fryers. Just wondering, you're obviously in a, this is towards the end of a scale-up process, I guess. What
Carry on.
what installations are actually in place already?
Sure. Yeah, so we're probably nearer the start than the end, I would say. So this is a system that's been under development for a number of years. We've got our first full system prototype that's going live in September this year. So unfortunately, this isn't yet on the market, but first full system will go live in September. Then we've got a number of units going in Colchester. That will be towards the end of next year that those go live. The prototype is in Nottingham, and that's where we're based. So yeah, do come and visit.
Thank you very much. I was wondering what the sort of plan area is of one of these sites.
Yeah, good question. So the unit comes in 20-foot shipping containers, and it will typically be 3 to 4 containers. We'll make up one 150 kilowatt, 750 kilowatt hour system. So just a slight wrinkle to that. 2 of the containers will be stood upright. So if you imagine two horizontal containers, 2 upright, it's roughly 30 foot by 20 foot for a module. So to put that into context, it is a bigger system than a lithium-ion system. It's not this. We're not going to see this in inner London. It does require a bit of space, but actually the lifetime, affordability, sustainability makes it interesting.
Hi, Charlotte Hill from Drax. Do you have an understanding of how the ambient conditions are going to affect the longevity of your storage and your efficiencies?
That's a really nice question. So because we store our heat at 400 to 500 degrees C, fluctuation of 5 or 10 degrees kind of in the ambient conditions doesn't have any impact on us. If we go to very high altitude, then the air is thinner. But actually we have a solution to that, which is not unfamiliar. We actually turbocharge our engines. So we just manually force more air into them. So it is a flexible solution in terms of being able to operate where it's cold, where it's hot, where it's high, where it's low. We don't go underwater, but pretty much everywhere else we're interested.
Any more questions?
I was going to save that for last. We've got another question over there in a minute. But no. So the name Cheesecake, no marketing professionals were harmed in the naming of this company. So this was engineers only when we branded the company. I don't know if it shows. We had an acronym for our technology, which to us made sense. I won't go into exactly what it stands for, but it was 8 letters long. It was Cheesecase, and that corrupted over time into Cheesecake, and it stuck. So thank you to everyone who came just to find out what the name was. I really appreciate the support.
That was my question. No. How far can this energy travel? So you mentioned about the sets that you've got in Colchester. How far in terms of distance are you providing that energy to?
Sure. So it's a locally focused system. So it will operate at low voltage. So what that means is we're looking at kind of basically within one substation. We're not going to be, obviously we can supply to the grid. It would be pretty much kind of within a few hundred meters would typically be the focus. For the microgrid, that actually extends things. So it could be kind of up to a kilometer or more where there's microgrid infrastructure. But typically we'd see this co-located with a solar farm, co-located with an industrial facility, and actually everything is close together. Turns out copper is expensive. So long wires are not necessarily the way to go. So, yeah.
One last question, I think.
Hi, yeah, thanks. So how fast does the power dispatch the energy?
Yeah, so the unit is 150 kilowatts so we can ramp up to that speed relatively quickly when we're spinning. If we are stationary, so if we'd been shut down for a while, then we will need a bit of time to spool up in the same way that a diesel generator would. Actually, there's a lot of similarities between us and a diesel generator, except the emissions. We're not a fast frequency response solution. So other technologies do that really well. we're happy to leave them to it. This is about moving power kind of en masse, kind of from certain times of the day to other times of the day. We can provide inertia because it's synchronous electrical machines, which is often valuable. But yeah, we're not a sports car. We're more like a truck in terms of the way we respond.
Great. That's all we've got time for. So thank you, Michael.
Lovely. Thank you all.